Welcome to our deep dive into the fascinating world of nanomaterials. Today we'll explore what nanomaterials are, why they're so unique, and how they're transforming industries all around us. Nanomaterials are materials with structures at the nanometer scale. Think 1 billionth of a meter. At this tiny scale, materials often display remarkable properties, such as increased strength, lighter weight, or enhanced chemical reactivity. These features make nanomaterials a hot topic in science and technology. In the coming scenes, we'll uncover their types, properties, and the incredible ways they're being used in our daily lives and future innovations. Start by defining nanomaterials. A nanomaterial is any material with at least one dimension sized between 1 and 100 nanometers. To put that in perspective, a human hair is about 80,000 nanometers wide. At the scale, the rules of physics and chemistry can change, giving nanomaterials their unique characteristics. These materials can be made from metals, ceramics, polymers, or even biological substances. Their tiny size allows them to interact with other materials in ways that bulk materials simply can't, opening up a world of possibilities for innovation. Nanomaterials come in several forms, each with its own set of properties and uses. The main types include nanoparticles, nanowires, nanotubes, and nanofilms. Nanoparticles are tiny spheres, often used in medicine and electronics. Nanowires are long, thin structures with excellent electrical conductivity, making them ideal for sensors and circuits. Nanotubes, like carbon nanotubes, are incredibly strong and lightweight, while nanofilms are ultra-thin layers used in coatings and electronics. Each type brings something special to the table, and together, they form the backbone of nanotechnology applications. What makes nanomaterials so special? It's all about their properties at the nanoscale. When materials are shrunk down to just a few nanometers, their surface area increases dramatically compared to their volume. This means more atoms are exposed and available to interact, leading to enhanced chemical reactivity, improved strength, and even new optical or magnetic behaviors. For example, gold nanoparticles can appear red or purple instead of gold, and carbon nanotubes can be stronger than steel yet lighter than aluminum. These unique properties are the foundation for countless new technologies. One of the most exciting applications of nanomaterials is in the field of electronics. Thanks to their tiny size and exceptional conductivity, nanomaterials are used to create faster, smaller, and more efficient electronic devices. For instance, carbon nanotubes and graphene are being used to develop next-generation transistors, flexible displays, and even quantum computers. These advances are making our gadgets lighter, more powerful, and more energy efficient, paving the way for a new era in consumer electronics. Nanomaterials are revolutionizing medicine in ways that were once unimaginable. Their small size allows them to travel through the body and deliver drugs directly to targeted cells, improving the effectiveness of treatments and reducing side effects. Nanoparticles are also used in imaging, helping doctors detect diseases like cancer at much earlier stages. In addition, nanomaterials are being developed for use in tissue engineering, regenerative medicine, and even as antibacterial coatings for medical devices. The future of healthcare is being shaped by these tiny but powerful materials. Energy production and storage are being transformed by nanomaterials. For example, nanostructured materials are used to make more efficient solar panels, capturing more sunlight and converting it into electricity. In batteries, nanomaterials can increase capacity, reduce charging times, and extend lifespan. Fuel cells and supercapacitors also benefit from nanotechnology, leading to cleaner and more reliable energy solutions. These advances are crucial as we move toward a more sustainable and energy-efficient future. Nanomaterials are playing a key role in protecting our environment. They're used in water purification systems to remove contaminants at the molecular level, making water safer to drink. In air purification, nanomaterials can capture pollutants and even break down harmful chemicals. Some nanomaterials are designed to clean up oil spills or remove heavy metals from soil. By harnessing the unique properties of materials at the nanoscale, we can develop cleaner, greener solutions for some of our planet's biggest challenges. Construction industry is also benefiting from nanomaterials. By adding nanoparticles to concrete, we can make it stronger, more durable, and even self-cleaning. Nanomaterials are used in coatings that resist dirt, bacteria, and graffiti, keeping buildings cleaner for longer. Some advanced materials can even repair themselves when damaged. These innovations are making our buildings safer, longer-lasting, and more sustainable, changing the way we design and maintain our built environment. Nanomaterials are making waves in the textile industry too. By incorporating nanoparticles into fabrics, manufacturers can create clothing that's stain-resistant, water-repellent, and even antibacterial. Some textiles can block UV rays or regulate temperature, making them more comfortable and protective. These smart fabrics are not only practical but also open up new possibilities for fashion and functional clothing. From sportswear to medical uniforms, nanotechnology is weaving its way into our everyday lives. Food safety and preservation are being improved with the help of nanomaterials. Packaging materials enhanced with nanoparticles can keep food fresher for longer by blocking out oxygen and moisture. Some nanomaterials have antimicrobial properties, helping to prevent the growth of harmful bacteria. Smart packaging can even indicate when food is spoiled. These innovations are reducing food waste and making our food supply safer and more reliable. Cosmetics industry is embracing nanomaterials to create products with improved performance. Nanoparticles are used in sunscreens to provide better UV protection without leaving a white residue. In creams and lotions, nanomaterials help active ingredients penetrate deeper into the skin for more effective results. These advances are leading to safer, more efficient, and more appealing personal care products. Athletes and sports enthusiasts are benefiting from nanomaterials in their gear. Nanotechnology is used to make sports equipment lighter, stronger, and more durable. Tennis rackets, golf clubs, and bicycles made with carbon nanotubes or nanocomposites offer improved performance and comfort. Even sportswear can be enhanced with nanomaterials for better moisture management and odor control. These innovations are helping athletes reach new heights and enjoy their favorite activities even more. Automotive industry is leveraging nanomaterials to build safer, more efficient vehicles. Nanocomposites are used to make car parts lighter and stronger, improving fuel efficiency and safety. Nanocoatings can protect surfaces from scratches, corrosion, and UV damage. Some advanced sensors and batteries in electric vehicles also rely on nanotechnology. These developments are driving the future of transportation, making cars smarter and more sustainable. Aerospace engineering is another field where nanomaterials are making a huge impact. Lightweight, strong nanocomposites are used in aircraft and spacecraft to reduce weight and increase fuel efficiency. Nanomaterials can also improve thermal protection and resistance to extreme conditions. These advances are helping us explore new frontiers, from commercial aviation to deep space missions with greater safety and efficiency. Farmers are turning to nanomaterials to boost crop yields and reduce environmental impact. Nanoparticles can deliver fertilizers and pesticides more efficiently, minimizing waste and pollution. Sensors made with nanomaterials help monitor soil health and plant growth in real time. These technologies are making agriculture more precise, sustainable, and productive, ensuring food security for a growing global population. Environmental monitoring is becoming more accurate and responsive thanks to nanomaterials. Nanosensors can detect pollutants, toxins, and pathogens at extremely low concentrations, providing early warnings of environmental hazards. These sensors are used in water, air, and soil monitoring, helping to protect public health and the environment. With nanotechnology, we can respond to threats faster and more effectively than ever before. Catalysis is a process where a substance speeds up a chemical reaction without being consumed. Nanomaterials are excellent catalysts because their large surface area allows more reactions to occur at once. They're used in industrial processes to make chemicals, fuels, and even clean up pollutants. Nanocatalysts are making manufacturing more efficient, cost-effective, and environmentally friendly. Photonics is the science of using light to transmit information. Nanomaterials are enabling breakthroughs in this field, such as faster fiber optic communications and advanced lasers. Their unique optical properties allow for the manipulation of light at the nanoscale, leading to new devices for computing, imaging, and sensing. The future of high-speed communication and data processing is being shaped by these tiny materials. Sensors made with nanomaterials are more sensitive and selective than traditional sensors. They can detect tiny amounts of chemicals, gases, or biological molecules, making them invaluable in healthcare, environmental monitoring, and security. These nanosensors are helping us gather more accurate data and respond to changes in our environment more quickly. Battery technology is getting a major boost from nanomaterials. By using nanoparticles and electrodes, batteries can store more energy, charge faster, and last longer. This is especially important for electric vehicles and renewable energy storage. Nanomaterials are helping to power the future, making clean energy more practical and accessible. Fuel cells convert chemical energy into electricity, and nanomaterials are making them more efficient and affordable. Nanocatalysts improve the reactions inside fuel cells, while nanostructured membranes enhance performance. These advances are bringing us closer to widespread use of clean, hydrogen-powered vehicles and energy systems. Supercapacitors store and release energy quickly, and nanomaterials are making them even better. By increasing the surface area of electrodes, nanomaterials allow supercapacitors to store more charge and deliver energy faster. This technology is important for applications that require quick bursts of power, like electric vehicles and renewable energy systems. Clean water is essential, and nanomaterials are helping us achieve it. Nanoparticles can remove contaminants like heavy metals, bacteria, and viruses from water more effectively than traditional methods. Some nanomaterials can even break down pollutants, making water safer for drinking and the environment. These advances are crucial for global health and sustainability. Air quality is a growing concern, and nanomaterials are providing new solutions. Nanofibers and nanoparticles can trap tiny particles, allergens, and even viruses, making air filters more effective. These advanced filters are used in homes, hospitals, and industrial settings to protect our health and improve indoor air quality. Paints and coatings are being transformed by nanomaterials. Nanoparticles can make surfaces more resistant to scratches, stains, and UV damage. Some coatings are self-cleaning or antimicrobial, reducing maintenance and improving hygiene. These innovations are used in everything from buildings to cars to electronics, making surfaces last longer and perform better. Hospitals, schools, and public spaces are using nanomaterials to create antibacterial surfaces. Silver nanoparticles, for example, can kill bacteria and prevent the spread of infections. These surfaces are especially important in healthcare settings where hygiene is critical. Nanotechnology is helping us create safer, cleaner environments for everyone. Delivering drugs to the right place in the body is a major challenge in medicine. Nanomaterials can be engineered to carry drugs directly to diseased cells, improving treatment effectiveness and reducing side effects. This targeted approach is revolutionizing how we treat conditions like cancer, infections, and chronic diseases. Medical imaging is becoming more precise with the help of nanomaterials. Nanoparticles can be designed to highlight specific tissues or diseases, making it easier for doctors to diagnose and monitor conditions. These advances are leading to earlier detection and better outcomes for patients. Tissue engineering aims to repair or replace damaged tissues and organs. Nanomaterials provide scaffolds that support cell growth and tissue regeneration. These materials can mimic the natural environment of cells, leading to better healing and integration. Nanotechnology is opening new possibilities for regenerative medicine and organ transplantation. Regenerative medicine is using nanomaterials to heal and restore damaged tissues. Nanoparticles can deliver growth factors or genes to stimulate repair, while nanoscaffolds provide a framework for new tissue to grow. These advances are helping patients recover from injuries and diseases that were once considered untreatable. Cancer treatment is being transformed by nanomaterials. Nanoparticles can deliver chemotherapy drugs directly to tumors, minimizing damage to healthy cells. Some nanomaterials are designed to heat up and destroy cancer cells when exposed to certain types of light. These targeted therapies are improving survival rates and reducing side effects for cancer patients. Nanomaterials are being explored for their antiviral properties. Some nanoparticles can block viruses from entering cells or disrupt their structure, making them useful in preventing and treating viral infections. These materials are being developed for use in coatings, masks, and even antiviral drugs, offering new tools in the fight against infectious diseases. Diagnostics are becoming faster and more accurate with nanomaterials. Nanosensors and nanoparticles can detect diseases at very early stages, sometimes even before symptoms appear. These technologies are being used in rapid tests for infections, cancer, and other conditions, enabling earlier treatment and better outcomes. Smart materials can change their properties in response to external stimuli like heat, light, or pressure. Nanomaterials are at the heart of many smart materials, enabling them to adapt and perform new functions. These materials are used in everything from self-healing coatings to responsive textiles and sensors. Flexible electronics are made possible by nanomaterials like graphene and silver nanowires. These materials can bend and stretch without losing their electrical properties, leading to new devices like foldable phones, wearable sensors, and flexible displays. Nanotechnology is making electronics more versatile and integrated into our daily lives. Data storage devices are becoming smaller and more powerful thanks to nanomaterials. Nanostructures can store more information in less space, leading to higher capacity hard drives and memory chips. These advances are essential for the growing demands of digital technology and big data. Quantum computing is a cutting-edge field that relies on nanomaterials for its development. Quantum bits, or qubits, are often made from nanoscale materials that can exist in multiple states at once. These materials are enabling the creation of computers that can solve problems far beyond the reach of traditional machines. Robotics is advancing rapidly with the help of nanomaterials. Lightweight, strong materials make robots more agile and efficient. Nanosensors give robots the ability to sense their environment with incredible precision. These advances are leading to smarter, more capable robots in manufacturing, healthcare, and beyond. 3D printing is being revolutionized by nanomaterials. Nanoparticles can be added to printing materials to enhance strength, flexibility, or connectivity. This allows for the creation of complex, high-performance parts for use in medicine, aerospace, and electronics. Nanotechnology is expanding the possibilities of what we can create with 3D printing. Artists and designers are exploring nanomaterials to create new visual effects and textures. Nanotechnology can produce colors and finishes that change with light or angle, leading to innovative artworks and products. These materials are inspiring creativity and pushing the boundaries of what's possible in art and design. Security systems are becoming more advanced with nanomaterials. Nanosensors can detect explosives, toxins, or unauthorized access with high sensitivity. Nanomaterials are also used in anti-counterfeiting measures such as invisible inks or unique identifiers. These technologies are helping to keep people and information safe. The military is using nanomaterials to develop advanced gear and equipment. Lightweight armor, improved sensors, and stealth coatings are just a few examples. Nanotechnology is enhancing protection, communication, and performance for soldiers, making modern defense systems more effective. Despite their many benefits, nanomaterials also present challenges and risks. Their small size can make them difficult to control, and there are concerns about their impact on health and the environment. Scientists are working to understand how nanomaterials interact with living organisms and ecosystems, and to develop safe handling and disposal methods. Responsible development is key to realizing the full potential of nanotechnology. Looking ahead, the future of nanomaterials is incredibly bright. As research continues, we can expect even more innovative applications across every industry. From medicine to energy, from electronics to the environment, nanomaterials will play a central role in shaping our world. By harnessing their unique properties responsibly, we can solve some of humanity's greatest challenges and unlock new possibilities for generations to come.